Okay, so for today, we're looking at the PSI, and the PSI stands for Problem Solving Investigation. So it's just a way of looking at the story problems and going through and identifying what you have, laying out your strategy, how you're going to approach this problem, and then applying your strategy. And then at the end, checking to make sure that your answer makes sense. Um, Sometimes on when I'm grading papers or tests, it's like, how in the heck did they think that this was the right answer? When you go up from $28 to $34 and someone says that's a 500 and some percent increase, it's like, okay, they don't understand what a percent increase is. So let's look at case number one, the shooting star. So Laura wants to make the girls' basketball team and knows that making free throws is a skill that impresses the coach. In practice, she makes 3 out of every 5 free throws she attempts. In tryouts, she has to shoot the ball 30 times from the free throw line. How many of these can she expect to make? So, the first step in solving this problem is identifying what we know. What are the facts? So, she is there and is she a proficient free throw shooter? Oh, 3 out of 5. That's a 60%.
It's above average.
It's above average. Okay. Um, so let's see. So we know that she makes 3 free throws out of 5. And the other information that we know is that she needs to shoot how many? 30. She needs to shoot 30. Now, the way I put this information down there, someone might say, hey, what's a strategy that we could do this with? We could do this with proportions. We could do this with percentages. Is there any other way that we could do this? Any other strategy that we could use to solve this?
I just uh I just divided.
You just divided. And tell me about your division. What'd you do?
I just hit 30 divided by 5. Whenever that was, I times that by 3.
Okay, so you were using basically the proportions, and you saw that 5 went into 30. So what do you have to multiply 5 by to get 30? And that was your 6. And so you went up here and you multiplied this by 6 and got 18. So that's the amount that we could expect to do that. So if we were doing it not that method, but with cross multiplication, it would look like this. 5x equals 90. We would divide by 5, and we would get x equals 18 that way. So you can do it this way proportion-wise, and that works because 5 goes into 30. You can do it this way proportion-wise, and this would be the cross multiplication that we could use when if we didn't realize that 5 went into 30. And then the other strategy is we could use percentages. The percentages, so 3/5 is equal to 60% or 0.6. So we want to know what 0.6 of 30 is. And if we multiply 0.6 times 30, we're going to get 18. So any one of those strategies works. It's just a matter of how do you see the problem? So we have done step 1. We've planned it out. We kind of talked about those strategies. We solved it using the strategies. We solved it actually 3 times using the different strategies. And we're going to check and make sure our answer makes sense. Does it make sense that out of 30, she's going to make 18. Well, we said before 3/5 was a little bit above average. Average would be 50%, right? So 18, half of 30 is 15. 18 is a little bit above 15. So, yes, the problem does make sense. Let's look at this one. So, Tomas looks through a window and sees the top 3 rows of a 7-row display of digital cameras. He sees 4, 6, and 8 cameras in these rows. How many cameras are there in the whole display? So we know that we're seeing the top 3 rows. We know that the top row has 4 cameras on it. The second row has 6, and the third row has 8. So let's talk about planning out some strategies. Anyone have any suggestions on how you want to do this? We could continue the pattern. We could see, is this a proportional display? No, these fractions don't reduce down to the same thing. So we're not going to use proportions. What else do we have in our strategy box for this one? Anyone think of anything else?
I was going to say continue the pattern, but
Okay. Well, let's just that's a way that we can do it. So let's just continue the pattern. So if I continue this out, I'm going to come down here. What is our 4th row going to be? How many cameras on our 4th row? It's going to be, we're adding 2 each time. So it's going to be 10. 5th row is going to be 12. 6th row is going to be 14. And 7th row is going to be 16. So we know that in the 7 rows, how many cameras are there in the whole display? So we have each of the rows added up there or figured out. So what do we have to do to figure out how many are in the whole display? Yes, we're going to have to add all those rows up. So 4, 6, 8, 10, 12, 14, 16. And when I add these up, I am going to pair them up. 14 and 16 add up to be 30. 8 and 12 add up to be 20. And 4 and 6 add up to be 10. So I still have this 10 up here that I have to add in. So 10 plus 10 is 20. Another 20 is 40. And 30 more is 70. So another strategy, because we were looking for the total number, is rather than writing each one of these out, well, we would start with that. Maybe we can see something that, okay, if this is the row, this is how many cameras per row, and then this is the total number of cameras. Some people might want to jump to this and say, and see if they can see a pattern with that. Do we see a pattern with that? Well, if we go and we add the 4th one, that might help us see the pattern a little bit better. So what are we adding here? 6, 8, 10. What are we going to add the next time? 12. That's going to bring us up to 40. What are we going to add the next time? 14. That's going to be 54. And then we're going to add 16, and that will be our 70. So either way, we're looking at patterns and we're continuing out that strategy. So this whole assignment, you're going to be doing the 4 cases that are on page 227. You're going to look at those and you're going to try and identify some patterns that are going on there and see if you can't answer the questions that they're asking. Any questions from you guys?
Nope.
Okay.
Nope.